So, hello everybody, welcome to my channel. In today's video, we are going to do spectrum chapter of physics. So, let's start. So, deviation produced by a triangular prism. This is the first topic of this chapter. So, when a ray of light passes from one medium to the another, it gets deviated from its path because of its difference in speed of light in two media. The deviation produced by the triangular prism is shown below. So as you can see, so there's a incident ray passing through it, and due to which it get bent towards the normal as it's going from rarer to denser, and then away from the normal rarer to denser. So when you calculate those angles of the angle PQB is delta 1 and angle SR and just a second. So let's see, say this A. So SRA. So this angle and we just and this angle are known as delta. So this is delta 1 and this is delta 2. Okay. So now let me tell you one thing. Delta 1 plus delta 2 is equal to delta, which is angle of deviation. So with this, this is the concept of the deviation, which we have already done in a what we say, we have already done this in previous chapter of light, which was refraction of light in plane surface. I believe that was the chapter. As you can see, it's delta is equal to delta 1 plus delta 2. So so they are dependent on the three factors. Okay, so first one is the incident of the surface. Okay, so when the incident of the surface and the incident line moves, the it differs in the refraction of the light, which results in deviation. Then the angle of prism, what angle is it? So basically in this diagram you can see it is an equilateral prism of 60, 60 and 60. It's an equilateral prism. Okay, so if it would be 90, 45, 45, it would okay. So yeah, so that's for deviation. So now let's begin with our next topic. So yeah, so now we will do dependence of deviation on color or wavelength of light. So light of different color have different speed in medium. So this we have already done in previous chapter of refraction of light at plane surface. So the speed of light in a transparent medium decreases with the decrease in the wavelength of the light. So it's basically trying to say that the speed of light in transparent medium decreases and the wavelength also decreases. Okay, so there's a connection. If the speed of light decreases, the wavelength decreases. Therefore the refractive index of glass increases with the decrease in wavelength of light, so the deviation increases with the increase in wavelength, a decrease in wavelength. So what is this? So basically when a refractive index increases, the wavelength of light decreases, and when so due to that deviation increases and wavelength then decreases. So that's the concept between these wavelength and the refractive index. So thus the red color has most has the least deviation. So lambda is equal to 7000 Armstrong, and whereas violet has the most deviation, which is lambda 4000 Armstrong. So now recombination of color, the color of spectrum of white light combined to reproduce white light. The two prisms combined together efficiently act like a parallel side glass slab. This experiment shows that P1 simply disperses the white light into the constituent color, and the prism P2 recombines these color to form white light again. None of the two prisms produce color by itself. Now electromagnetic spectrum, the proportion of the spectrum between red and violet color is known as visible spectrum, and this is the only small part of our entire electromagnetic spectrum which we are able to see. The proportion of spectrum just beyond red light is called infrared spectrum, and the proportion just before violet light is known as ultraviolet spectrum. So now there are many waves under it, and there's a formula. The speed of light is equal to the speed of light in a medium into the frequency, which is lambda. So you have to remember this, which is a very important formula for numericals. Now, dispersion of white light due to prism formation of a spectrum. So when light, as we know, when white light passes through prism, it decomposes into seven colors, which are Vibgyor, violet, indigo, blue, green, yellow, orange, and red. So because of this, rainbow is also formed as a drop of light act as a prism in. Okay, so now dispersion and spectrum. The phenomena of splitting of white light by the prism is constituents color is known as dispersion. The band of color obtained on the screen on passing a white light through a prism is known as spectrum. So cause of dispersion, the dispersion is caused due to the change in speed of light or frequency. Okay, so now so the next one is properties of electromagnetic wave. These waves do not require any material or medium to propagate as sound requires. But the sound chapter we will do in next to a video, some other videos. So they travel at the same speed in vacuum or air, which is same as the speed of light. With the speed of light is everybody, as you know, 3 into 10 to the power 8 meter per second. Okay, so now let's start with gamma rays. So it is the most energetic electromagnetic radiation of the wave, which has the less than 0.1 Armstrong or 0.1 nanometer. They are obtained in emission of radioactive substance due to energy change in the nucleus of their atom. Like X-ray, they can cause fluorescence when they strike fluorescent materials such as zinc sulfate. They can easily penetrate through thick metal sheets, and they can easily penetrate through human body, causing immense damage. They are used in medical science to kill cancer cell, in industries to check welding. Now X-rays. As we all know, X-rays pretty much, as this is the very frequent term used by the doctors surrounding us. So X-rays are produced at when a high energetic cathode ray are stopped by a heavy metal target of high melting point. They have the wavelength in the range of 0.1 Armstrong to 100 Armstrong. So they are chemically more active radiation than the ultraviolet radiation. They strongly affect a photographic plate. They causes fluorescence in the material such as zinc sulfate. They can penetrate through human body, but they are stopped by the bones. Uses, they are used in CAT scan in medical science. They are also used for studying atomic arrangement in crystal as well as complex molecule. They are used by the detective agents to detect precious metal. So now ultraviolet radiation, these are mostly emitted by the sun. Ultraviolet radiation can pass through quartz, but they are absorbed by glass. These radiation travel in a straight line, as every electromagnetic spectrum wave can travel in straight line, because those all are light. So the speed is also same, 3 into 10 to the power 8 meter per second in air or vacuum. They are usually scattered by the dust particles present in the atmosphere. They obey the law of reflection and refraction. This point is also followed by every ray in the spectrum. So now they produce fluorescence on striking the zinc sulfide screen. Okay, so they are used for sterilizing purpose, for the detection of purity of germ, egg, ghee, etc., and they produce vitamin D. So now what is visible light? These electromagnetic radiation of wavelength is from 4000 Armstrong to 8000 Armstrong. These are called radiation, visible radiation. The sun and electric bulb, a flame of hot bodies, the main sources of visible light. The these color help us to see. These color are mainly consist of Vibgyor, which is violet, indigo, blue, green, yellow, orange, and red. So they are used for photography, photosynthesis, and to see object around us. Now infrared radiation. So what are these? These travel in straight line as every other light do, with the speed of 3 into 10 to the power 8. As I already meter per second, I already tell that every light travels in this speed only. Okay, so now what are they are used? They are used for therapeutic purpose by the doctor. They are used by the photography at night and also in mist and fog, because they are not scattered much. So they penetrate appreciably through these. Okay, so now they are used in the remote controller of television and other gadgets. Now microwave, These waves are produced by electromagnetic devices such as microwave. Okay, so these wave ranges from 10 to the power 7 Armstrong to the 10 to the power 11 Armstrong. Their frequency ranges 3 into this frequency ranges 3 into 10 to the power 11 hertz to 3 into 10 to the power 7 hertz, used for satellite communication, for analyzing atomic molecule structure, for cooking, in microwave ovens, and in radar communication. So radio wave, these waves are longest wave length among all the electromagnetic waves. They have wavelength above 10 to the power 11 Armstrong or 10 meter of frequency below 3 into 10 to the power hertz. They show all the property of electromagnetic wave. Uses, they are mainly used in radar communication and radio and television transmission. So yeah guys, that's up for today's video. Please like, share and subscribe. Thank you.